want to make sure everybody knows. Did it jam again? I think these things.
No, I'm just disabled those twice.
You sure that was what you took over you? Go back. Did you print it here? Okay. There. Let's see.
How did you put the thing back down?
How did you get it back down?
I didn't look it up very far.
Oh. Just don't lift it up too high. Well, you push something down. You got the paper out. You gotta. Oh. Oh. This doesn't sound good. Oh, those are. It could be old plastic stuff. Oh yeah, that's the old stuff. But the plastic ore. She did hers twice. So, there's only one in here, she paid for it twice.
I'll just try to print it again.
Come on, here, that's okay, you can go. So, did you get an acceptable card?
Yeah.
Not opposed, because it looks like popcorn.
Where's the stamp? It's fine.
I don't see it. I don't see one.
I wasn't sure. I'm not good with them. I wasn't sure what was going on.
Now that, did you get something before? No, wait a minute, she just printed one.
No, I didn't print it yet. I'm waiting.
Oh, were you waiting for them? Apparently it's working,
Okay, I want them.
so, but
Okay, are we good? Yes.
this is yours. All right, we're getting, sorry. Ah,
Yay. Winning.
okay, so does everybody know how to put things into Shobi? And now we have homework due in Shobi that's worth 15% of your grade. So, you go to the worksheet and you click on it, and when you're in under your name, it'll have a plus sign. You press the plus sign, and you can hit add from computer or add from device. This will let you go to any file you want, say a picture. Now, and people that have old, somebody with an Android phone, it works. They went to Shobi website. They hit the plus sign and hit file, and then they gave them the option to use your camera. So even Android phones work with this. The plus sign on your Android phone, go into Shobi.com on your phone when you're using Wi-Fi, through Wi-Fi, and you know, so you're not paying for it. So it's plus, and it works. It lets you choose the camera. Okay. Okay. Now your stuff, I was able to see it. I didn't actually need. I was wasn't able to see it on the iPad. So I don't, you did upload it successfully, even though it wouldn't come up on this computer. That's fine, but if you're not sure about it, you can, you can paper copies. Okay. But I just extended the time for the Manatee worksheet until Saturday at noon. Okay, I know we don't have class Saturday. You got your devices, you can take pictures if you don't have it done. If you have it done, it's fine. I don't know where the stapler is, so, no. Nope, no stapler. You know, I get some,
I'll literally pull them off. That's what I was
oh no. Okay, how did you do yours? When you were in B2L, you were doing like that, how did yours go? Yeah, did you download it too? Somebody downloaded yours. I know, if somebody printed it out without downloading it, that's what's happened, you get one page and it's worthless, and then you pick up somebody else. So, all right. We're gonna go over the sample tests. If, okay. Now, just a minute, we've got. Is this the last one to print? Okay. All right, the sample test. Okay, so the levels of measurement. Just to review, so what are the levels of measurement? There are 4 levels of measurement for data, and we can classify data again as categorical or quantitative. So I'm just reviewing this a little bit with you. This is chapter 1. And categorical is also called qualitative. And then we have the 4 levels of measurement. If something is categorical, it can be nominal, ordinal. If it's quantitative, it can only be interval or ratio. Okay, so, and it's best when you're trying to figure out the levels of measurement is to decide if it's qualitative or quantitative first. Because if it's qualitative or categorical, it will only be nominal or ordinal for the levels of measurement. If it's quantitative, it can only be interval or ratio. And remember, this is names only. Like this could be type of car, whether you have a Chevy, a Ford, whatever. Ordinal has a low to high or high to low order. Interval, and these are labels though. And the order has to mean something too for it to be there. Interval has negative numbers or the scale starts over. So, interval would be like time and temperature, or the year. And temperature, because temperature has negative degrees Fahrenheit and degrees Celsius, has negative numbers. Ratio, and these are numbers. And these are ratios, everything else that is a number, and it makes sense to take an average. You can take an average on this side too. So ratio has a 0 starting point. Natural 0 starting point. So if someone has 0 children, they really don't have any children. But if it's 0 degrees outside, in Fahrenheit, then there is a temperature outside. It's just very cold. Okay, so that was chapter 1. It's been a while, and chapter 1. So see if you can answer these questions. What's the level of measurement? First, is this qualitative or quantitative? If you got a letter grades, would that be qualitative or quantitative? If letter grades is A, B, C, D, or F, so they're not a number. So maybe I should be using the word categorical. It's categorical. Because letter grades, the final letter grade you earn is not a number. I know it's based on numbers, but it's A, B, C, D, or F, right? It's ordinal, right? So it's categorical, and then it has an order from high to low. So it's B is ordinal. Okay. I guess I'll use the word categorical instead of qualitative. I'm having trouble telling when you're saying quantitative or qualitative. All right. Okay? So a list of years the Summer Olympics were held. Would that be quantitative or categorical? Quantitative. So then the level of measurement can only either be interval or ratio. So which one of that is that? It is interval. It is because the scale on years started over. Yeah. Right. So that's C. A list of, if you got ages of students with health professions as a major, ages of students, is that quantitative or categorical? Quantitative, yeah, right. And so since it's quantitative, the level of measurement can only be interval or ratio, so which level? Ratio, you got it. Okay, good. So, just a review of that. All right, and then see if you can figure out the next two. Write down what you think it is, and then we'll talk about it. Got it written down. All right. So, what do you guys think? Is surveying some adults by telephone, is that an observational study or an experiment? Right. It's observational. And the difference between an observational study and an experiment actually provides a treatment. It splits them into two groups. So, of course, so the next one is what? Right. Okay. All right, and then we got the types of sampling. Simple, random, stratified, cluster, systematic, or convenience. So we've got law enforcement officials use a radar gun to measure. So please take a minute and fill in what you think they are, and then we'll talk about it. All right. Okay, so if you're going to measure the speed of every 10th vehicle, what kind of sampling is that? Right, okay. You got this. All right. A sample of 20 college students is taken from each county of Tennessee to fill out a survey on current events. So it is stratified. So what's the difference between stratified and cluster? Right, right. So this is stratified because we took some from all the counties, and if it was cluster, we might have, it would say that we took all the voters from some randomly selected counties. All of some, so a local business randomly selects 4 area gyms and surveys every member. So it just says he randomly selects, so which one's that? Oh yeah, you're right, that is C. Okay, this is cluster. He randomly selects the gyms and he surveyed every member. That's what I was just saying. That is cluster. There you go. Okay, so that's numbers 9 and 10, discrete or continuous. The number of cylinders in a car. How many, can there be a half a cylinder in a car? Can there be 0.2 cylinders in a car? So, can there be -6 cylinders in a car? Alright, so the number of cylinders is discrete. It's a count. It's a count. And then with the amount of nicotine, and any time it's a measurement, this is a measurement. So anytime it's a measurement, it's continuous. That's how you tell the difference, and that's quantitative data. We split up that way. Oh. And I thought I had, right before class I printed out a blank one of these. I'm having trouble with printing too. Ah. The thing. Okay. All right. So, all right, parameter or statistic. And this is basically what you need to know from chapter 1, these terms. So, a parameter is a number that describes the population. A statistic is a number that describes a sample, and they start with the same letter. So you got to figure out if they're talking about a sample, if this is about a sample, or is this about a population. So what do you think? So So is the 123.7 million a statistic or a prediction? It is, because it's a sample. He randomly selected 35 movies. How many movies are there in existence? I mean, way more than 35, so. Anyway. So this is a statistic. And among the senators in the current Congress, 44% are Democrats. So, is this about a population or a sample? There's 50 senators, and it just says among the senators, so that applies to all the senators. It's a parameter. Oh, the 44% is a parameter, A. Do you have questions about parameters and statistics? So it's implying that it's all the senators here. It's nice when I use the keyword all though, but sometimes the question will say, took a sample of 6 from all or something. Be careful. But, alright, and then you need to know these symbols. So do you know these symbols yet? They're all listed in D2L. You need to memorize these symbols. I might have them in, I don't know if I have a Quizlet on that, but I have them listed. So, the population variance is sigma squared. Sample size is small n. Interquartile range is IQR. Sample standard deviation is S. Quartile 3 is Q subscript 3. Population size is capital N. Population mean is mu. Population standard deviation is sigma. Sample variance is S squared. And one data value or an observation is just an X. And those are, you need to know the symbols for this test. And then you need to be able to construct a stem and leaf plot. So, did you guys get the symbol? So there's more symbols. I have them listed on a sheet in D2L. Construct a stem and leaf plot. You want a descriptive title. This is about the ages of residents in a village in Alaska. So you want a title. It can be, I'm going to just put it on the bottom. Ages of residents in a village. I'm sure somebody could come up with a better title than that, but okay. And then you're gonna need your stems and your leaves. So your stems for this problem, and it's gonna be the tens, either tens or write out ten, T-E-N. And the leaves are the ones. Now that's not always the case. If the data was in the hundreds, we might have the stems be the first two places. The leaves are always the last decimal, the last place. So your data's in order here, and it goes 1 through 32. So you can put 0 for the tens, and then 1 to represent anything in the tens, 0 for anything less than 10, 1 to represent everything in the tens, a 2 to represent everything in the 20s, and a 3. And then you just list them. You'll put 4 1s. It's in order. And all the 2s, and a 3, 2 3s, and I'm probably gonna run out of room. But I'm not gonna give you this kind of data. You would keep going all the way up to 9. Okay? You won't put dot, 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 but you get the idea. And then there were 3 10s, so you'll have 3 zeros representing 10, 10, and 10, 4 11s, 2 12s, a 13, a 15, 2 16s, a 17, and a 17. And that's all in the 10s. And then you got the 20s. 21, 2 of those, 22, 3, 4, 5, 6, 27, 2 of those, 2 28, and a 29, and that's it. And then you got 30 and 31, 31 and 32. And that's how you make a stem and leaf plot. You've got to have your label that shows the values, and you don't skip any numbers here, and you got a title. Village, I don't know why. Oh.
Say like if you didn't have any tens, and you would still put something on,
Yes.
and you would not put anything after the one, right?
Right,
Okay.
right. So if we didn't have any 10s, then we'd still have this 1 here, but there'd be nothing listed here. Yeah. Okay? So that's the stem and leaf plot, and you've got to draw one on the test. So, and then if you look at that distribution, is it symmetric, skewed right, or skewed left? So you can turn it on its side. And remember, this kept going way up there. So most of the data is on the left, and the tail would be on the right. It's skewed toward its tail, so it's skewed right. And if you wanted to make a histogram with 6 classes, what class width would you use? So class width, this is, I did put that on the formula sheet. I got a formula sheet here. So it's something like this. Class width is the maximum data value minus the minimum data value divided by the number of classes, and then you need to go up to the next whole number. Yeah. I think it's posted online. This is what the formula sheet looks like. Formula sheet for test 1. You don't have to use these formulas, though. We use the calculator to find these things. But it does have that on it. The lower fence, the upper fence, the range, IQR, class width, coefficient of variation, minimum usual value, and max usual value. So I do give you a formula sheet. You get to use the formula sheet, your calculator, and scrap paper. That's it. Okay? So is this skewed? So the class width then is the maximum, since we're starting with a list of data, we're going to do class width is the maximum data value minus the minimum divided by the number of classes, 6. So the maximum was 32, the minimum was 1, and divided by 6. You get 31 divided by 6. And if we do that on the calculator, we get 5 point something. Where's my calculator? Bring the calculator up. (31) divided by 6 is 5 point something. So you always go up to the next whole number on class width. Even if we had gotten exactly 5, the class width we'd have to use is 6. question? You have a question, Richard? Yeah. Yeah, and I think it's posted online in D2L, so I'm not currently in D2L, I'm a Shobi. I don't know if it's even posted in here sometimes. Test 1 notes and PowerPoint, let's see. Ah. There it is. Yes.
Is there any way on the test you can label if you want us to round up to the nearest whole number and the nearest decimal? Because on the homework, we're supposed to round up to the nearest decimal, and now we're supposed to round up to the nearest whole number, and it's not the same.
Okay. Class width, you're supposed to know that you have to go up to the next whole number. So I will say, round to 2 decimal places as needed, like the calculator practice of that, or I'll say things like that. But class width, you have to remember that you have to go up to the next
So
whole.
if it doesn't say round to the nearest decimal, then that obviously means round up to the nearest whole.
No, not necessarily. It's class width. If you're doing class width, you're gonna have to go up to the next whole number. Class width matches the data, and we're only doing whole data, so it's always a whole number. So you're gonna have to remember that about class width. It's not regular rules of rounding at all on class width. Okay. All right. Thank you for asking that question. Okay, so does everybody know how to enter data in the calculator? And I do ask that you label each answer with the correct symbol. And this samples test didn't tell you to round to 2 decimal places, but but I'm going to make sure the test says that, or how many decimal places. Now, so it's just class width. That's that weird rule right now. And otherwise you lose, when you make the distribution, you leave out the maximum value. So you're going to put these in the calculator, and you can find the mean, the standard deviation, the variance, and the coefficient of variation. So what are the symbols, though, that go with this? It's a sample, so you need sample symbols, and you need to know your symbol. So what's a sample? What's a sample mean? It's X bar. And on the test, I had blank equals and a bigger blank to point out that I want the symbol. Again, I'm asking for them. Standard deviation is S. You're going to type this stuff in your list 1 and do 1 variable stack. Variance is S squared, and coefficient of variation, use the abbreviation CV for the symbol. Okay. And CV is, it's even on the formula sheet, S over X bar times 100%. So, does anybody need help putting this in the calculator? Help with the calculator? You know how to put this in? You put this data in the calculator and do 1 variable statistics. And I'll walk around and help you if you need it. I think I have. I didn't do that one before. Nope, I didn't work it. You need help? doing 4 when you square it for this, but when they're taking it for 2, you can put the 4 over here in scratch board, but you know how much you square. You write it down as 2, but when you square it, you use 4 because you gotta write it in. Yeah. But you would use 4, you would use 4 for F and 4 for L, and then you only have 2, so you don't use. Okay. Six, okay, X, well, this tells us the mean. That means the sum of the x's, you got one, that's the sum of the x squared. And there's, you know, under content, there's a document that shows you, detailed calculator expressions. Chapters 1 through 3, and it actually points out what all that is. And then it puts a list in, and then it tells you what all that stuff is. So we're not gonna use some of the x's and some of the x squared. And then it tells you, you have to do the right standard deviation also. Standard deviation is population. And this is the same. Okay? Okay, so there's extra helps out there in D2L. Any questions? Did it? So I didn't do this one, probably. What'd you, here, I'll just put it in. Stat, edit, clear my list, 47, 55, 73, 76, 85, 74, 66, 80, and 73. Second, quit, stat, calc, 1 variable statistics. If we use list 1, that's the default. So, I want, no, okay. So, X bar is 69.89. But when I find CV, I want to use 69.8889 for X bar. S is 12.07 because I round to the second place. But when I do CV and when I do S squared, I'm going to use 12.0669. Or you use the calculator shortcut I showed you the other day. And I'm going to use these 4 decimal places when I find S squared. So S squared is going to be 12.0669 squared. That's the variance. And it's going to be 145.61. Coefficient of variation is going to be 12.0669 divided by 69.8889. And multiply that by 100%, and round that to 2 places in percent is 17.27%. Okay, so did you all get the same answers? And the next one's a gift shop, has this information. Here's the data. You're going to put that in your list 1. Do we need to take a break? Seems like we just started with all the printer mess, but all right. Well, we'll keep going. If you guys are not telling me so. You're in the you're working hard. Okay, list one. So you put this in your list one. Let's see. And your calculator will give you the 5-number summary. The 5-number summary is the minimum Q1, the median Q3, and the max. So the hardest thing is putting this in your calculator and knowing to do one variable statistics with it. And you'll find the 5-number summary and you just list it in order with commas. So put that in your calculator. Stat, edit, clear out the list. 4.75, 5.52, 6.25, 4.75, 5.75, 7.5, 6.75, 5.75, and 6.9, and 6.25. And there's 10 pieces of data, 1, 2, 3, 4, 5. That's 10. And make sure, double check on a test that you typed the data in right. Second, quit. Clear the screen, go stat, calc, one variable statistics, enter, and arrow down to see the 5-number summary. There it is. So the 5-number summary, and when my stat lab asks you for it, it's going to ask you for the 5 numbers with a comma between them. You just put them in order. 4.75, comma, 5.52, comma, 6, comma, 6.75, and 7.5. That's your 5-number summary. So how do you make a box plot? You use these to make a box plot. That's a box plot. You just use a 5-number summary. So this splits your data into quarters. We make a scale. We're going to go from like 4, 5, 6, 7, 8. And this is weekly sales. In thousands of dollars. Oops. And this is gift shop. You want a title, gift shop sales. Anytime you have a chart, you want to make a title. 4.75, about there. And the minimum is 4.75, the max is 7.5. You connect those, that's your whisker. And 5.52 is about here. 6.75 is here. You connect, that's your box, and then you draw a line for your medians at 6. And there's your box plot. So you make a box plot. You do need a scale. You do need titles. Okay.
It's online, it's not on paper.
What's
This
is my
is,
what?
no, is the real test, is it online?
Oh no, the real test is going to be on paper. No,
I was like,
I'm not putting it in Shelby. Oh. Okay. No, the real test is going to be on paper. So, and you'll have room to write, there'll be plenty of room to write on that, but you can use scrap paper too. Okay, so now how do you find the range? That's the max minus the minimum. that's 7.5 minus 4.75. .75 minus 4.75 is 2.75. And the IQR, the interquartile range is the IQR is Q3 minus Q1. That's 6.75 minus 5.52. So you need to label which is which. If I ask you to, and show your work, you can type it in the calculator, 6.75 minus 5.52, 1.23. And then it says, are there any outliers? Well, you're going to compute the lower and upper fences. The lower fences on your formula sheet as Q1 minus 1.5 times the IQR. Anything below this number would be, any data value below that number would be considered an outlier. But you don't have to memorize that, it's on the formula sheet. It's right there. And you got the upper fence too. So you do get this formula sheet, it's posted in Shelby and D2L. So maybe practice using it. Equals Q1, which is 5.52 minus 1.5, and the IQR is 1.23. You're just going to put that in your calculator. 5.52 minus 1.5 times 1.23. And you get 3.675, so that's 3.68 approximately. So any data value below 368 would be an outlier. Do we have any data that's below 3.68? It's actually in thousands of dollars, but we have no data below that, so there's no outliers on the low end. The upper fence is Q3 plus 1.5 times the IQR. So you got to use Q3 this time and not Q1. It's 6.75 plus 1.5 times 1.23. And don't add before you multiply. You have to multiply before you add, or type it in the calculator, it'll do the correct order of operations. Plus 1.5 times 1.23. And that's about 8.6. 8.60. Do we have any data above 8.60? The highest data value was 7.5, so no. So we have no outliers. You can just write that there's no outliers. You don't have to write that on the low end or the high end, but now if you had any data values above this, you would list those. Those would be outliers. Any questions on finding outliers? Okay, here's an example that's like a test question. If you are given a histogram, can you answer some questions about it? So here's a histogram, and it shows all members of the middle school's A and B basketball teams, and we are only interested in this particular middle school team's height. So this is a population. It's population data. So we're going to use population symbols. So first off, is the distribution symmetric? is the highest bar in the middle or about in the middle? No, it's over here, so it's not symmetric. Is it skewed right or left? Well, most of the data is on the right, but this is the tail is where the least data is. This is it's skewed toward its tail, so it's skewed left. What class width was used? So, if you see the single number under each bar, these are the class midpoints. And the class midpoints are the class width apart. So the class width is 54 minus 51 equals 3. They used the class width as 3. Now why didn't I use the formula max minus min divided by the number of classes? Because I already have a frequency distribution here. I have midpoints and I have frequencies. So I already have a table. So when you have the table already, the class width is either the difference between two consecutive midpoints or two consecutive lower class limits. We only use the formula max minus min divided by the number of classes is when we have the list of data. We no longer have the list of data. Okay? So use this information to determine how many students play basketball at this middle school. That would be this population size is n equals, and we'll add, for your convenience, I've put the numbers up here of the frequency so you don't have to guess what it is. It's pretty easy on this chart, but 5 plus 8 plus 12 plus 13 plus 11. Just add those together on your calculator. That is going to be 5 plus 8 plus 12 plus 13 plus 11. 49. And the symbol. Okay. And then to find the mean, median, mode, and standard deviation, this is a frequency distribution. You're going to have your midpoints are 51, 54, 57, 60, and 63. Your frequencies are 5, 8, 12, 13, and 11. You have to put this in list 1, this in list 2, and then you do one variable stats, and you have to tell the calculator that you have two lists. So you do list 1, comma, list 2. Stat edit, clear that list out, type in 51, or we could type in 5 copies of 51, but this is a shortcut, much easier. 54, 57, 60, 63. Then 5, 8, 12, 13, 11. Second quit. Stat, calc, one variable statistics, and then you press second 1 for list 1, comma, it's above the 7, second 2, and n should add up to 49 on the calculator. It will add, if you do list 1, comma, list 2, it will say on the calculator, it says n equals 49. You check that. You had 49 data values, not just 5. And then your mean is, and this is population data, so it's mu equals 58.04. The median, you arrow down to see that. it doesn't have a symbol, is 57. And the mode is the most repeated data value. These are your data values. So you look at the highest frequency, which was 12, and read the data value off 60. And then the standard deviation, since it's population data, you have to read sigma. It's 3.81, and we don't have to, it didn't ask for the variance, so 3.81. Any questions? Yeah.
Do you need a symbol for the standard deviation?
Oh, yes, sorry. Yes, we don't have a symbol for the mode, but we have a symbol for the standard deviation. Since it's a population, it is sigma, the little thing. Thank you. Very good. And then, is there, let's take a break. We're skipped 27. I don't ask that anymore. And we'll talk about the last few pages. Take a short break, 5 minutes. We'll come back and talk about the last pages. I'm going to pause this. Okay, so we've got a set of 25 data points. All right, so this is the concept question. Suppose we have 25 pulse rates. You know, we had pulse rate data in chapter 2. If we got 25 pulse rates, but all of them were recorded as 5 points lower than, that's really bad, nurse or something, or assistant. Recorded them all lower than the actual measurement. With this corrected, 5 points added to each pulse rate. What happens to these things? The median. So I say you can just pretend like we have some pulse rates of 65, 68, 70, say. And we don't have to list 25 values. Suppose this is how they were recorded. And then we add 5 points to each pulse rate. So the corrected ones are 70, 73, no, adding 5, that's right, and 75. So what happened to the median? I didn't have to list out 25 data values to figure this out. What happened in the median from here to here? The median's the middle value. If we add the same thing to each pulse rate, the middle value is going to do what? It's going to increase. If this is multiple choice, decrease, stay the same, or increase. When you circle it, don't circle 3 things or 2 things. Circle 1 answer. The standard deviation. What happens to the standard deviation when we add the same thing? Well, you could put it in your calculator and find the standard deviation, but standard deviation measures the distance from the mean. And if we add the same amount to each pulse rate, the distance apart, the data is still the same distance apart. So it's the spread of the data, so it will stay the same. The spread of the data didn't change. Okay? So you can make up numbers on a concept question like this and think about it. But, all right, your test grades. So you got 4 test grades. They count 40% of your grade. So we're going to make a chart, but first we have to take the average of these. We have to add these together and divide them by 4. So there is a problem like this on the test. This is a weighted average. So you're going to take 79 plus 92 plus 87 plus 80 and divide by 4. and you get 84.5 as an average. Okay? So we got tests, these are the categories. We have tests, these are your averages, or your X's. You have to put the average of the test grades in here. And then we have the weights, are the percents, at 40%, which is 0.40. Then your lab average, lab was a 94, it counts 15% of your grade. Your daily average was an 86 and counts 20%. And your final exam was a 79 and it counts 25%. So find your final average for the class. What's your final average? Okay, well, you found it. Did you take 84.5 times 0.40 plus 94 times this plus, no? Oh, you did it in list, yes, you can do it in list 1 and list 2, or you can use the formulas that X bar is the sum of the X's times your weights divided by the sum of the weights. Or you can put your X's in list 1, your weights in list 2, and do one variable stats, L1, comma L2. Either way. So, stat, edit, and I guess, do I have the answer to this somewhere? No, I just wrote the formula down. Let's see if I worked it on this one. No, I didn't. I must not have had very much time. Okay, so you can put this in your list 1 and list 2. So clear down arrow clears the list. 84.5, 94, 86, and 79. 0.40, 0.15, 0.20, and 0.25. Second, quit, stat, calc, one variable statistics. You have to tell it list 1, comma, list 2, or if you're using the stat wizard, the frequency list. So you did get, is that what you got? Good job. X bar equals 84.85, and you would have a B in the class. In this class, 90 to 100 is an A, and 80 to 89 is a B, 70 to 79 is a C, and 65 to 69 is a D, and below 65 is an F. That's how our scale goes anyway, so by our scale, that would be a B. Okay, the next one's about percentile. And, you know, that's actually not on the test, but this is true, and I'm not going to ask you to defend the answer. This is true, but only thing you need to know about percentiles is how to interpret them. Okay, now this is, remember, you need to remember there is something like this on the test. if you have a frequency distribution, that's what this is. You can find the midpoints, that's, you add the class limits together and divide by 2, or it's the middle number there, and on this data it's easy to tell that that's 63. The middle number between 62 and 64 is 63, and this is 66. And what's the class width? I didn't ask you that, but that would be 3. 69, and you can add the class width on the midpoints going down. Relative frequency is the total frequency. Let's do the cumulative first. It's 1, and then 1 plus 6 is 7. 7 plus 4 is 11. 11 plus 18 is 29. 29 plus 5 is 34. Relative frequency is the total frequency is 34, so it's going to be 1 divided by 34. And if we write it as a decimal, 1 divided by 34, and decimal to 2 places is 0.03. So we do the 6 over 34. The relative frequency is the class frequency over the total. Part over whole is 0.18. And I think there's a typo on my answers on this one. So 4 over 34 is 0.12. 18 over 34, 0.53. And 5 over 34 is 0.15. So you have to remember what relative frequency and cumulative frequency are for the test. Okay? We don't take the cumulative frequency and put it over 34. We take the class frequencies over here. So we filled in all that, and if you needed to find the best estimate for the mean and standard deviation of the data, you would put your midpoints in list 1 and your frequencies in list 2 and do 1 variable stats. List 1, list 2, and since it's sample data, you would say X bar equals whatever it was, and sig S equals. You'd read S on the calculator, and the calculator always says X bar. And then the value of Q1 will always be the 25th percentile. So, yes.
So you always round the relative frequencies to 2 decimal places? Because on the answer sheet, it says that they didn't round on your answer sheet. Because they have like they have 2.9%.
Oh, okay. I'll tell you what the round to.
Okay. Because I was guessing,
I usually write it in percent, but
is
here
that
I'm
one that
writing it.
cents would be 2.9, so 0.03 because they didn't round.
Okay, and I messed up on that one. That's fine. This is rounded less than what I did, but, and the last answer is wrong. But, I'll tell you how much to round to on that, or whether to give you that in percent. I think I'm just gonna do 2 decimals. 2 decimals, and I'll say that, 2 decimals. All right, so, are you guys feeling like we should take the test? I just reviewed for it. You ready to take it so we can spend more time in the harder material? Okay, we're gonna take the test, see this. I think you guys seem like you understood this stuff, yeah? No, okay, so that's a good question. You thought, well, and a lot of students think this, every time we've done a frequency distribution on the worksheets and stuff, it's always been a population. So maybe you think If it's a frequency distribution, we use population symbols. No, we look to see if the data is from a sample or a population. So good question, because I think, honestly, every time we've done a frequency distribution, it's been for population. You can get confused with that. All right, well, we're done. If you can stay and ask questions. We will have the test on Tuesday.